Okay, thank you. Thank you all. Thank you so much for having me on the Meekins Lab Open Science presentations. This talk is a bunch of preliminary results that are almost done, but not quite. So I might have some answers, but not all answers. And I research a lot in mathematical creativity, and I'll try to lay out the argument that there's a synergy between math creativity and humanness. But first, even though we're virtual right here, I still want to give a land acknowledgement to at least the land that I'm in. This is the Hasinas Caddo tribe and the Kirikiris, Wichita and affiliated tribes land. And so I think it's actually very important that I acknowledge that there are quite a few Native nations within Oklahoma. In fact, this was also a hunting and trading migration for other nations, but there's also 39 nations in Oklahoma. And I think it's really important to understand, acknowledge, and appreciate the nations here. I know that this presentation is on Twitch, so I'd like to get started with the presentation. We're going to go and grab 3, then 5. I got to grab 5. I got to get the 7. Oh gosh. Okay. All right. This was one of my favorite games, Number Munchers here. I have a bunch of questions for you all. I actually wanted to make this quite interactive in some sense. So some of the questions I have, and you can answer as much as you like or how you like. One of the questions I have is, what is your definition of mathematical creativity? And I'll let you all throw that in the chat. One of the interesting things that happens with me is that I go on airplanes and I talk with people. And when I say that I research in mathematical creativity, some of the people that I talk to look at me as if those two words are an oxymoron. And so I'm actually just curious to see what you all thought of your definitions of mathematical creativity. So I'll look at the chat a little bit to see what's going on here. I see some. New ways to visualize how math concepts operate. Oh, that's cool. And I'll try to check out some more here. Ooh, I like it here. Use math to design fun puzzles. Okay, interesting. All right. Oh, here's another one. Fastest way to hide as an imposter. And so, yeah. And the other question I have for you all is, do you think that beginning calculus students can be creative? And if so, in what ways? And I ask this because it's interesting. We actually asked this in one of our first studies as a research group. We actually asked a mathematician about math creativity, and we asked about fostering it in the classroom. And this teacher said, if it's a calculus class for engineers, I'd rather not get too creative with them. Just teach them the techniques and get it over with. I don't think they want to be creative. My impression is they just like to learn this. They don't want to become mathematicians. They don't want any fun or joy or anything. And that, unfortunately, is a quote that is sometimes all too common. Bowler and Greeno in 2000 talked about how many students, especially in lecture-based courses, felt a similar way. And so our major conjecture is to go actually totally against that. We have basically a series of implications that this rubric that we've created, and I'm not going to get into that today, but you can find it on our website, www.creativityresearchgroup.com. We say that this rubric implies that that can help instructors explicitly value creativity. If instructors explicitly value creativity, then we've shown in proving or in proof-based courses that there's a bunch of outcomes, including confidence, self-efficacy, math appreciation. But there's also some other outcomes, including valuing creativity, persisting, taking risks, and making connections. And while this is not our research group, it's been shown that affective outcomes can lead to persistence in STEM. And so we're trying to make this gap or this thoroughfare through creativity. And so some of our research questions for the first study that I'm going to show you are, what are students' definitions of mathematical creativity and calculus? And also, like, how do students view creativity and relate to creativity? And this is actually quite a big thing. And I'll get into it in just a minute. So let me go ahead and check the chat. I should make sure that I'm seeing. There's some interesting things here. Okay. Interesting things like, okay. Do you think the impression that engineers want joyless instruction creates or has created a feedback loop? Yes, yes. I hope you consider that. I think that's a good point here. Actually, why don't I not have, I kind of want to have this chat on the side here. All right, anyways, let me keep going here. So what are definitions of creativity, or how have they come in the literature? So unfortunately, our field has over 100 definitions of mathematical creativity. But you can kind of see the lineage or the delineation occur. Guilford was the first one to bring it up, and then Rhodes made a careful distinction about the unit of analysis of creativity, called it the 4 Ps: person, product, process, and press. So that means the environment that creativity occurs. You can investigate all 4 of those or any one of those. There's also a difference between absolute creativity, like creativity for the whole field, something brand new to the whole field of mathematics, versus relative creativity, creativity to the individual. There's a distinction about domain-specific creativity. And I know that there are many different researchers on this stream from many different fields. I'd like you throughout this whole process to think about what creativity is in your field, and specifically in the classroom, what goes on with creativity. Our group has offered a definition, a process. So we look at process-oriented, of offering new solutions or insights that are unexpected for the student with respect to their math background or the problems they've seen before. Now, this is interesting because research on definitions of mathematical creativity, especially from students, is quite scarce. So we're going to add to that with this study. Moore, Russo, and Demler have done it before with pre-service teachers, and our research group did it before with proof-based courses, but we haven't seen anything in calculus courses yet. So the data collection, let's get into this study here. We had 10 instructors from many kinds of universities. We're talking large research universities to very small universities. Some universities had coordination. So there was a person that had to also be in coordination while teaching all this, and obligated with what we're going to obligate them with. And then we had one teacher from the research group, and we collected it. The class size was very large, 150 students. We also had control classes. And so I do want to point out that the CB means creativity based and NC means non-creativity. So these instructors, there was no intervention at all. Let me talk to you about the intervention itself. We asked them to use 2 tasks that we give them, and then we asked the instructors to create 4 more. So they had to implement 6 tasks total. We had pre and post quantitative surveys, and we interviewed students and the instructors. And I'm not going to talk anything about the instructors interviews or that data collection, but I can share any thoughts and ideas about that side of the study because we have done a little bit of preliminary analysis on teacher beliefs, which I thought was very interesting. And then the last thing is that 37 students we interviewed were from the creativity-based course and 18 students from the non-creativity course. Okay, courses all throughout. All right, so let's get into the tasks from the research group. The first task that we gave them so that they can implement was consider the limit as x approaches 1, square root of x minus 1 over x minus 1. So this is a typical task that occurs in calculus classes. We ask them to evaluate this limit in as many ways as you can, okay? And I'm sure all of you are at home getting your pencils and papers out and writing up some ways you can evaluate this limit. But I actually want to ask you, and I'm going to throw it back on the chat. I want to ask you this question, this next question, and I want to see what some of the answers are in the chat. I'm ready. All right, here we go. The question is there a perfect circle in real life? All right, I'm going to go ahead and check out the chat and see what's going on here. Is there a perfect circle in real life? This is great. I love the Among Us shout out. Is 2D or 3D? I don't know. Depending the radio station. Okay. This chat is great. All right. I'll let you all cook on that for a little bit. I'll give you some incubation time. Actually, I don't even have an answer for you. I've heard some really, really interesting answers when posing this question. So what did we do in this study? One of my favorite ways of teaching is I can ask a question and then go away from it. And I love asking those kind of questions because I think that the uncertainty is one of the things that I really enjoy. I enjoy now feeling it, but I didn't before, that's for sure. All right, so data coding, what did we do with the responses from the interviews? So students were asked their definitions of math creativity and other questions dealing with creativity. So when we saw a definition or in the other questions, when they were responding with some type of definition of creativity, the first step we did was in vivo coding. So when you're qualitative coding, in vivo means that you're grabbing the code name from the person's own speech. And I'll explain this in a little bit. So the second step was taking all those codes and organizing them into categories, right? And then the third step was analyzing the categories for commonalities. Maybe we needed to mesh a category, or maybe we need to split apart a category. All right, so let me give you an example. So Gail is the interviewer here, and Gail said, what does it mean to you to be creative in mathematics? Angus said, finding a different means or method to, or means, method, or mechanism to evaluate an expression. Well, that we would have probably called the first code finding a different means or method, right? And then when we grouped them together, we would group that under the category of different ways, okay? And then Gail says, okay, what do you mean different from? Angus says, what's basically the written way? And so the written way is a sense of authority. And so what we did was we coded, okay, different from the written way was our first code, and then we moved it to outside authority, which is our category for that. And so we had 6 themes that came from students. This is, to me, it's really amazing, because what it says is there's a robustness that students have when dealing with mathematical creativity, and that I really enjoy. So let me quickly go through the 6 themes. The first one is different ways, just different techniques or solutions. The second one is understanding. So this refers to math creativity associated with understanding, learning, or making connections with content. The third one is application. So math creativity is some kind of application to some other situation, maybe even chemistry, right? The fourth theme is original. This is math creativity as creating new mathematics, right? And that's different from different ways, because one could know 3 or 4 ways to approach a problem and use those. But original means that you're creating something brand new to you. The fifth one is personal traits, an action they took, an attitude they had, or a feeling as creative. Joy, comfortability, et cetera, et cetera. And then the last one is outside authority. So this is a code where they say that creativity is outside or against what the discipline, class, textbook, or teacher designated as proper. And you'll see a little bit of examples of some of these, okay? So what happened? When we coded all of these 55 students, we had these totals for each of the categories. And so I do want to say that different ways was by far the most popular definition of mathematical creativity, but personal traits was number 2, and then understanding a little bit back in number 3. So this is quite interesting to me, because the students are associating math creativity with some kind of feeling or attitude associated with themselves, and this will come back. So I asked, what do you notice? What do you wonder? And I'll keep asking that with many of these things. The other thing that we asked the students was, did they feel creative in their calculus course? And out of all of the ways to sort students, this one question about did you feel creative or not yielded some very interesting differences in definitions. So I do want to say in our creativity-based course, that's CB right here, 27 out of 37 students felt creative in their class. Out of the non-creativity course, 6 out of 18 felt creative in the class. And so some of these numbers are not surprising, but me personally, I'm probably going to go back and spend like 5 weeks just pouring myself over the creativity-based non-creative students, and just trying to figure out ways to like tinker with what we're doing. So, or what we can enhance in the intervention. And so what's interesting is that if a student said that they were creative, you could see the numbers of instances for that. And if a student said that they were not creative, you can see the number of instances. And I bet you're probably looking at ratios, right? Like 18 to 24, 42 to 6. But you got to remember also that there's a 1.5 to 1 ratio here. And so again, probably the question is, what do you notice and what do you wonder? So I'll keep this slide up, and I'll put up the chat, I guess. What do you notice here? Yeah, so it seems like personal traits and original are the main responses. Yeah. I like the chat before with the circle. It's great. All right. So let me go back to the slideshow. So one of the things you mentioned there was that original is kind of a big ratio there. It's 7 to 1, but adjusted for the 1.5 to 1 in the ends, you're looking at around four to 5 times as many things. So if a student felt creative, they were 5 times more instances of original, the definition of mathematical creativity as original. And the same thing for personal traits. This is a little bit less than the original ratio. The other thing that jumped out to me was application. There's actually more instances in the not creative aspect or feeling of application than creativity. And I think that I'll speak just minorly about that because I don't really have a good explanation for it. But actually, I'll skip that for now. We may talk about that after the presentation. All right, so case 1, Angus. We saw this. This is Angus's definition of creativity, right? Then Angus says, or Gail says, did you feel creative in your Calc 1 course? Angus said, do I feel? No, not at all. And Gail says, why? And Angus says, I have a hard enough time understanding the concept as is much less trying. I don't spend any time trying to think of a different, better known way to do it. I'm trying to understand the fleshed out known methods. So Angus doesn't feel like there's creativity at all because he's got to know what's going on with the fleshed out methods, right? But you juxtapose this with JCRU. And by the way, if you see this right here, we're relaying to you all their self-identified gender, self-identified race, and whether they were in the creativity group or the non-creative. JCRU says, I think it just means to be open and recognize that something doesn't have to be in the box, right? So openness, right? And then you can just go about different ways of solving it, or even thinking about math and how it can apply. But you'll see this definition, and then remember, Angus said that they didn't feel at all creative. This class felt like that gave her a chance to be creative because she was making up her own problems, and she was able to approach it and really understand it to be able to apply different rules to it. So you're seeing here a lot of definitions of mathematical creativity. Creativity is understanding, creativity is application, and making up the problem with their own originality, right? But what happened? JCRU says, I feel like this is the most confident I've felt in the math class and probably the best I've done so far. And I guess I could generally be way more creative than I thought in the past because I didn't associate the word creativity and math. Thought that was a very interesting thing. There's also some outside authority examples that I want to point out because I want to make a kind of a big claim here. Um, Cassie Kim says that she definitely thinks it's important to be creative because oftentimes going on your own path might be more helpful to you than the way a professor or teacher is teaching it, right? And JD says, I wasn't doing it myself, doing the math herself. I was just learning the process of my professor. The course was very rigid. It was hard to move out of the box of the lines because there are so many concepts we had to learn in a short amount of time, right? And this is all outside authority right here. So why is this important? Well, there's a concept called math agency. And Sengupta Irving says that school mathematics generally fails to help students see themselves as capable and making and remaking their world, which from a Freirean perspective defines human agency, right? Capable of making and remaking your world. Well, it seems like this also goes into ownership a little bit. Gutierrez says, when students view mathematics as something one does for oneself, there's greater likelihood for play, invention, or simply expressing themselves. And Langer and Asuna says authoring ideas can develop identities for students as powerful mathematical thinkers, right? So to me, I see these 6 themes. Remember, they're different ways, understanding, application, original, different ways, original, personal traits, which are gigantic here, and outside authority. All 6 of these play a part in agency and ownership, right? When you have different ways, then you can play around and use one of your ways, which is making or remaking, right? Or play. All of these words, play, invention, expressing oneself, these are personal traits, right? Original, authoring ideas, even, outside authority is a challenge against power and authority. So I believe that creativity and agency and ownership connect into being more human. This is my attempt at a meme. All right. Before I get into the second study, are there any questions? I'm looking at the chat here. This is great. I hope I didn't lose anybody with this here. All right, let me go ahead and, question. Have you explored the differences in application of subjects by students in their math heavy? No, we have not. And that would be especially moving stuff around. We have a question here about how calculus help their other courses. And so I think that would be one thing that I would really like to investigate or look into for sure. That's a great question. All right, let me go ahead and keep going here. It is 10:13, so I should be a little bit quick here. All right, next slide here. How can we foster it? So if creativity leads to like this agency and ownership, right? How can we foster it in the classroom, and what are the effects of it, right? I think these are kind of a big deal to us, right? Because we believe a lot in mathematical creativity and how much it can afford others, right? So what we did with our data collection was we collected, you remember we talked about the feeling creative and not feeling creative. We did ask a follow-up question to some, especially in the second cohort that didn't feel creative. We asked them if they were not creative, were others in their classroom creative? And so with any of those answers, once they said that they felt creative or that others felt creative, any teaching actions that occurred in order to help that creativity, we coded. And so then after we coded those actions, we then coded the affect, the beliefs, attitudes, emotions, and feelings that came from those teaching actions. And then we themed both of those, and you'll see the themes again. So this is another qualitative design here. So the 5 themes we paired into 2 categories for fostering creativity. The first theme is design. So when you're looking at how you're designing the course, I should say this, I'm sorry. Students said that these actions foster creativity. So this is not from us, the researchers, or from the teachers, but the students themselves. We didn't look at anything else yet. And so the students said that the design of the class tasks and then how they were assessed were big on fostering creativity, and then implementation. We broke it up into 3 themes. One is instructor-centered, active learning, and emotional space. And I'm going to focus a lot on emotional space because it's kind of a key teaching action here, or a set of teaching actions. Okay, so I have some quotes here. I'm going to go through a little bit quickly because I know I've got a little bit of time. So in the design, the task assignment, so Abby said that they had to create and solve their own problems. And so the task of creating and solving your own problems was a design part, right? And then the assessment. So Juniper is the teacher, would kind of grade them saying, oh, that's interesting, like the way you found that, which was really nice, right? And you also notice right here, the affect coming from it. It's really nice, right? And so I'll try to point that out some more with these quotes here. So implementation, teaching-centered ones are actions that are very near to the teacher. And that's kind of juxtaposed against the active learning, which is more student-centered, right? So Aon said, I feel like the teacher, making different subjects connect, being abstract with it really helped me be creative when it comes to math. Because I feel like today, I think this is actually quite key. This is an affect part. If you give me a problem, I'll be able to think of it in different ways. An active learning implementation quote was that Victoria said, there's a moment when someone was doing something, they were doing it, it wasn't wrong, it wasn't the easiest route. And so I just said, like, you need to do this. And the professor encouraged me, go ahead and say it, because you had to do it a different way on the board. So in the class, there was people that went up to the board and wrote up their solutions. And so this is an active learning classroom. And we define it when we're writing it up, we define it using some other citations of definitions of active learning. But the emotional space was, I think, one of the key implementation actions. So NK says that Gail said, what have you learned from your own problem solving abilities? And NK says, it kind of makes you feel bad about like solving your question, but in the class, I'm sorry. NK is talking about previous years and talking about something that it made you feel bad about solving a question, but no matter what the formula you use in this class, the more creative you were, even if you made a mistake, it was valued. So it meaning the mistakes or the different formulas, and the teacher, the instructor, valued that. So I think that the class kind of made me more confident affect about thinking whatever I want to do and knowing it would not be something dumb to do, right? These are kind of key here. And in fact, we have a ton of emotional space actions. And I think one of the big things here, if you look down, there's encouraging taking risks, inspirational talk, focusing on process, de-emphasizing correctness, promoting ownership, right? Like excitement, encouraging, use of different resources, positive encouragement, appreciating different ways, caring about students. All of these are actions that don't need a student reply or a student feedback, right? These are actions that are not like solve this problem, but rather kind of supporting and helping and encouraging. And the women in the creativity-based course, and this is so far cohort 1, and I'd love to see the stats on cohort 2. Hopefully we'll get done with that analysis by end of January. But the women in creativity-based course were 2.7 times more likely to report creativity fostering actions, but especially with the emotional space, they were 4 times more likely to have emotional space actions. And that's huge. These emotional space actions are huge for retention in CS and software engineering. And I haven't seen much in terms of the, they call them in the literature academic emotions, which is very interesting. And I need to dive a little bit more into that literature to figure out what's going on in both math education, and I think one of the big things that I conjecture is that math anxiety would lessen, probably with a lot more of these emotional space actions, as you can see with NK's response. And so I equate a lot of this stuff, the teaching-centered stuff, or not teaching-centered, but the teaching action stuff with math power. So this is kind of set in a sociopolitical or sociocultural stance. And I love reading Dr. Rochelle Gutierrez a ton. And she defines, or she talks a little bit about math education as a whole. And she stated that rarely do our definitions of success include self-actualization. We could become better by our own different definitions, not just prescribed by schooling. And then she goes on and says that teachers may also define success by looking for ways in which students are being creative, right? Or when students see a more positive relationship between themselves, mathematics, and their futures. That's a lot of emotional, academic emotions, emotional space actions. And so Gutierrez defines math power by who gets to talk or decide the curriculum, opportunities to use math as an analytic tool in society, alternative notions of knowledge, and rethinking the field of math as more human. And I'd argue many of the actions that the students showed foster creativity are align a lot with voice in the classroom, alternative notions of knowledge, and rethinking the field as more human. And Cobb, Grisalfi, and Hodge says that authority concerns the degree which students are given opportunities to be involved in decision-making about the interpretation of tasks, reasonableness of solution methods, and the legitimacy of solutions. So they're a part of it. And you can see with many of these actions, including active learning, the tasks that set them up for this, and emotional space actions, they can have a say in here. And so, I promised you all what would be the effects of these actions. And I promised you all as well, I'm going to be finishing up pretty soon. The affective outcomes are huge. Students talked about being more creative, or stuff about affect about creativity. They talked about enjoyment, liking it. They talked about comfort, that they felt more comfortable in the classroom. They talked about understanding more mathematics because of the fostering of creativity. They talked about self-efficacy and their confidence in approaching problems. They talked about valuing different ways. We saw that as well with the definitions. Persistence was a big one, that they would attempt problems and go more and more due to the fostering of creativity in the classroom. There's some negative affect too. Students felt frustrated. they felt like they were wasting their time after an action that fostered creativity or fostered creativity for someone else in the classroom. There was also some negative affect that they recognized were productive, like it didn't make sense, but I learned a lot from it. I don't know if that was the exact quote, but it was pretty close to it. And then finally, agency. We come all full circle. Students felt agentic. They felt like they were in control or command of what was going on with the mathematics. So to me, creativity fostering and power and authority connect for being more human. Thank you. I'm going to show myself out. I've got a huge thank you to Dr. Benjamin Meekins and the Open Science presentations. I got to thank NSF and the funding that we got for this grant and for this project. I got to thank my own family. You see them right there. And then I got to thank a group of 5 individuals who I work with weekly, daily, who are incredible. They're supportive, a lot of emotional space actions in the research group. And so my last audience question to everybody, so in your field or major, what is creativity? And in your classrooms, when you're taking classes, how's creativity fostered in your field? That's it for me. Thank you for attending. I will take any questions, comments, thoughts, frustrations.
I will start by saying, first, we have a ton of questions, so we'll get to those in just a second. And I have quite a few myself, but I won't be greedy. I'll wait. So anybody in the chat, that if you have more questions, please feel free to ask them as we go. We don't really have a time limit here, so I'm happy to go as long as people are still asking questions. But I will say this was fascinating. I had an idea of what you might talk about, and it was something completely different, and it was way better. So that was really cool, and I honestly learned a lot, and I'm gonna hope with some of my questions I'll learn even more. So let's get started with the questions. So Dr. Kothapalli wanted to know, do you think that the silos that are created in hard sciences and life sciences lead to differences in creativity beliefs?
Maybe. I don't know. I think that's a difficult question. And I think it's even more difficult to me because I'm not sure. So it's interesting. I actually sat next to a chemistry educator at the last ROOM conference, which was the ROOM stands for Research in Undergraduate Math Education, RUME. And I asked what was creativity in chemistry. And then I also asked what was creativity in chemistry at the undergraduate level. And there was a lot of pause, right? And I think that's really interesting. Like, I actually would love to promote like asking the question, what is creativity in the STEM fields in their own respective fields, then breaking the silos and trying to find out what's common and then what's like specific to each of the fields. I think we'd find a lot more common than we would specific.
That's an interesting point, and I tend to agree. So Dr. Kopali also wanted to know, have you explored about the differences? Oh, I think you actually answered this one. I'm sorry. Does peer pressure regarding creativity affect the students' persistence in math courses? That's interesting.
I don't know.
Okay.
I think one thing we're looking at right now is we're trying to do a lot of follow-ups with students, at least from the first cohort, since it's been a year now. A lot of things are kind of difficult, kind of contacting them, and then COVID for
Yeah.
another reason. But but I think that, it's interesting. The question about peer pressure, I think, can be. I don't know. I don't know what the definition is, but if I could sidetrack that for a second and say that I've been reading a lot about how persistence occurs with indigenous undergraduate and graduate students.
Hmm.
And one of the big aspects is community. So it may not be peer pressure, but rather peer support that kind of leads to persistence.
That's an interesting way to think about it. This is a good one. How do instructors respond to the comments and suggestions regarding creative application of concepts?
Yeah, I don't know. I feel like I'm dodging a lot of questions. I'm not sure how the instructors respond
Mhm.
about applications. I know that there are some instructors that have applications in calculus classes. I mean,
Mhm.
it's almost inevitable that that's going to occur. Um, I think what's interesting, though, is that some instructors encouraged their students to seek applications.
Okay.
So I think that that's a way to like foster creativity as well, because sometimes one perspective, the perspective of the teacher, it's not as strong as like 30 perspectives,
Hmm.
and also it's not as knowledgeable sometimes. And one of the interesting emotional space actions was that the students can, or I'm sorry, the instructor acknowledges that they can learn from the students. I think
Hmm.
that's a key one too, and that can play into those application type problems.
That's fair. That's a good point. When you have that back and forth, it I think you're right. I think it helps with the fostering interactivity. You just saw what she said, right?
Yeah,
You said she wanted to ask you
I
some hard
love this
questions.
chat. I love this chat here. This is great news. Um,
Yeah, we have a good time. Um, Dr. Ho wanted to know it- how would you respond to comments from students like Angus who said there's already a lot of difficult material to grasp, and so they don't feel like they can be creative.
yeah, I mean, that right then and there, it's much more psychological than it is mathematical,
Hmm.
or it's much more cognitive than it is anything else. And so,
Hmm.
I think one thing that I would try to do personally is talk with Angus about like what what things does he have control of, because
Okay.
it clearly from the quotes, and I'll go back to Angus's quotes here. um, th- there's I'm trying to understand the fleshed out known methods, right? Like
Hmm.
um, that's that's something that someone else has created, that's not like uh, personal to him. And
Yeah.
so what happens there is that um, it's kind of like a distance psychologically
Hmm.
that can create a distance in many ways to many other math concepts, right?
Okay.
And so I try to work on building up confidence with Angus,
Hmm.
and trying to see where he has power, he has some kind of agency,
Okay.
and then kind of build on that, right?
Yeah.
I didn't say this in here, but uh, this is quite a deficit kind of mentality right here, and similar to the one instructor here, this is a
Hmm.
deficit mentality. And Adi Reja, a good friend of mine, Dr. Adi Reja, talks about the anti-deficit approach. to both research, and I have tried to figure it out in my classes towards education.
Okay.
And to just look at what students are bringing to the table that are powerful, that are actually quite novel connections. Maybe they're not the same as what I have, and maybe they're not always right, but they can put some things together that really kind of amaze me.
Okay.
Yeah.
That's cool.
So I want to say hello to somebody. I see Open Science.
Yeah,
I've
that's me.
seen a lot of nailed it. Oh, thank you.
Yeah.
Kothapalin.
Yeah, like that's Dr. Kotapali, yeah.
All right. MF Honey Badger. I see you. And we have Happy Kitten 62.
Yep, that's Dr. Ho. She was
great.
actually one of our other education presenters. When she gave a talk a while back about some of the work that she had done in her class, introducing actually a lot of these creative things. Is Honey Badger one of your students?
No, colleague of mine.
Oh, very good.
Friend too.
All right, good.
Love it. Love it.
Always good to be supported.
Among Us. I was supposed to play Among Us on here.
Oh no.
I do want to say, I know this is going on YouTube, so I'll do this joke then. I feel like using Twitch and Discord is like when my parents saw DVDs for the first time, and they were like, "What's going on?"
Absolutely. Yeah, it takes a little bit of getting used to, but I like the possibilities are pretty good.
This is great. Yeah.
Let's see.
Any other questions?
Yeah, I've got a couple more here. So Dr. Ho also wanted to know, how do you assess creativity and how do you design your assessments to foster the creativity?
That is a absolutely great question. Okay, first, how do we assess creativity? The answer is we took, I would say, at least 3 years trying to figure this out. And we landed upon not assessing it ever, but rather letting students assess their own creativity. Okay. And so are you all still sharing screen here?
Yeah, you're still shared.
Okay, so let me go ahead and go. I'll show you all, if I can drag it over here, and go to the CRG website. So just to let you all know, you could go to www.creativityresearchgroup.com. Yes. And in here, we have a thing called the Creativity in Progress Reflections. And I want to bring this up because these are tools. They're 2 pages that are research-based that allow students to gauge their own creativity. Basically, what they do is they'll go through a problem, and then they'll gauge themselves on how much that they did in this problem and made connections between definitions, right?
Okay.
Or in the other page, how many times did they pose questions, right? Mm-hmm. And so what we advocate for is that students grab these rubrics and they judge their own creativity. And in that sense, we're not the ones that are gauging their creativity, because we don't know actually. Something relative to one student could be incredibly something not novel to one student could be incredibly creative to another student. Mm-hmm. And so we went through a whole bunch of iterations, versions, until we got to this version. And not only do we love it, but there were some students in the if I may go back, we also have that was on proving, but we also have a problem solving one.
Hmm.
And so what we've done is the students actually reported that they printed out sheets of this so that they could gauge their own creativity without even being assigned it. So
That's really cool.
I think it's incredible to me. Yeah.
That's really fascinating. So I guess we'll kind of piggyback off of what you just said. So Dr. Kothapalli also wanted to know, because creativity is not going to be the same for everybody, how do you kind of balance it in a classroom?
Yeah, I think it's the relativeness. How do you? I should have answered how to design assessments to foster creativity. So I'll answer
Oh, sure.
Dr. Kothapalli's one, which is how, I think one of the things I usually do is when it's a creativity. Now, let me put it this way: when it's a question like, "Is there a perfect circle for in real life?" One thing I will do is I can't say, you know, yes or no, because people can justify it in different ways. And it's interesting. We ask this in Calc 1 because the concept of perfect is extremely interesting, right?
Mm-hmm.
Like, I don't know, I've got this glass right here, right? Is this
Yeah.
a perfect circle? Well, probably not. There's a little bit of error inside of it, right?
Mm-hmm.
And that error could be the epsilon that we're talking about in calculus, right? So
Yeah.
it could be considered a circle plus or minus epsilon, right?
Yeah.
And so that was our in with the creativity in calculus. But I saw in the chat there was there was somebody who said the circle of life,
Mm-hmm.
and I've heard some of those questions, and so is that perfect, right? So and then I have a slide, but I'd have to find it. That someone put this, one of our instructors put this on as a discussion board,
Mm-hmm.
and there was probably like 20 to 25 answers that went through
Wow.
these philosophical conversations about what is perfect, what is a circle, et cetera, et cetera. So yeah, and to answer, you said Dr. Ho,
Yes, Dr.
Happy
Ho.
Kitten
Mm-hmm.
60. Okay. How do you design your assessments to foster creativity? One of the other subgroups that we have is looking at tasks to foster creativity.
Okay.
And I'm not going to ruin a lot of that, but one of the most common ways that instructors have changed tasks to foster creativity
Mm-hmm.
have been to take a task, let's say, let me see here. Let's say we have the integral from 1 to 2 of x squared.
Okay.
This is quite a common calculus task, right?
Very, very nice
And by the
writing with the
way,
mouse, by the way. That's that's impressive.
so so you all are probably going on your paper or pencil and everything else. All right, anyways, instead of asking something like this,
Mm-hmm.
we can ask, let's take an integral from 1 to 2 of some function, right?
Mm-hmm.
And I'll ask you, like, okay, if it equals, let's say, 32, give me the function that
Mm-hmm.
works for that and show me, like, prove it to me.
Yeah.
And so what happens now is that the student has to kind of reverse engineer what's going
Mm-hmm.
on here. Or as I would do, probably integrate this and then multiply it by something, right? Like
Right.
some constant times this to get 32.
Yeah.
But then you can ask them, like, find 3 different formulas or
Mm-hmm.
3 different functions, right?
Yeah.
And now they're kind of exploring, now they're playing. I think more of those are kind of um, one answer one way questions are nice,
Mm-hmm.
but I'm not sure if they I think there needs to be a balance between that and allowing students to be themselves.
Mm-hmm. Okay. So, all right, Rama has asked one more question, but I'm going to save it because she has specified that it's to end the talk. So I'll go ahead and ask a couple that I have. If anybody else in chat has more that they want to ask, please feel free to ask while I'm asking mine, and we'll get yours. So the first one I'd like to ask is how, and I know this is still kind of preliminary, but how wide-ranging do you think that you could make this? Because like I have a 5-year-old, she's in kindergarten, but there, she's doing some math things now, and Common Core, of course, has caught a lot of flack because people look at it and go, they're not teaching it the way I learned it. But when people actually step back and look at it, they go, okay, they're learning the same concepts, they're just learning it different ways, so that everybody kind of has a chance. You can figure out what way works best for you. But I'm wondering if some of the lessons that you're learning from this work, I mean, could it, how far down in terms of difficulty of mathematics could it go, do you think?
The same thing that I presented in terms of integral from 1 to 2 of x squared dx, you could do the same thing with, you said 5-year-old?
Yeah.
Right? They might be just recently into the conception of addition, right?
Yep. Yeah, she's doing 10 grams and addition and subtraction.
Yeah, and so like something like you had 5 plus 5, right?
Mm-hmm.
You can pose that and she'll say 10. Okay, great. Now can you give me 2 numbers that add up to equal 10?
Oh, okay.
Right? And then how many different numbers?
Yeah.
Right? And so again, it's a reverse engineering, but it allows for them to play a little bit.
Mm-hmm.
And one other thing is, I think all of these emotional space actions can go from 0 to 100 years old, right? Like,
Okay.
just like promoting ownership of learning, right? De-emphasizing correctness. When my daughters, when they would say 10 here for 5 plus 5, I'd say to them, instead of yes or no, I'd say, how did you do that?
That's
right?
a good
And
way to do it.
it's getting them to not only own the answer, but to explain the answer. Because I think a lot of students, and I cannot emphasize this enough, a lot of students, whenever you pose a question or a task, they're going to look right back at you and say, well, or they'll say the answer, but they'll look immediately at you right afterwards. And so they're trying to figure out from you, from your actions, from your words, if they're valid.
Yeah.
But you're going to be gone from their lives. Not totally.
Sure.
I'm going to be honest. But like they're going to go on to future things, right? And so they can't rely on you, right?
Yeah.
So I think fostering how they can rely on themselves is a key thing here.
Okay. I think that's a good way to look at it. How, kind of, I guess along similar lines, how do you think this could be adapted to, kind of like what Rama had asked earlier, how do we start breaking this out into chemistry, biology, engineering of all stripes? Because the statement, what Angus, or no, not what Angus said, well, I guess kind of what Angus said, but also what the teacher you had at the very beginning said, where students want just this joyless kind of not almost like rote memorization. I thinking back, I would say I was probably guilty of some of that. Like I enjoyed the work, but there were times where I definitely was like, all right, I want to know how to get from point A to point B the most efficient way possible. So let's get this done. So what kind of things can we start to do there to impart some of this creativity that is I think could be very powerful.
Yeah, so I'm actually going to flip that question on you and all of the participants, because to me, I'd like to ask in an introductory chemistry course,
Mm-hmm.
Where do you think students could be creative, right?
Okay.
Where do you see some play in there?
Mm-hmm.
Um, I don't. I honestly don't know, and I'd ask the same thing of the beginning engineering course, which
Yeah.
I don't know where that's at, but or a beginning biology course or a
Yeah.
beginning physics course, right? Like
Mm-hmm.
where where can we allow all of this, the power, the authority, the ownership, the agency? Where
Mm-hmm.
can we see students kind of be themselves? I think one of my key philosophies as an educator is that I want students to bring just a small amount of themselves into the classroom.
Mm-hmm.
I know I didn't.
Yeah.
I did. I did exactly what the teacher told me, and then that's it,
Yeah.
right?
Mm-hmm.
Um, and so that was not me, you
Right.
know. And so I think I challenge you or anybody to think about ways that someone could bring a piece of themselves into the classroom. And
Mm-hmm.
then you're going to see some creativity because they're invested in it, right?
Mm-hmm.
That piece, that 10% of themselves is there. Um, and I don't know, I'm going to go, I'm going to stop here, but I
Okay.
think my whole philosophy on education is hope.
Yeah.
um,
That's
and
fantastic.
it's kind of like making sure that students, yeah, they get some skills, but that they
Mm-hmm.
also get some like not psychological actions
Mm-hmm.
that can help them out later on in life.
Yeah.
Actually, okay, I'm gonna stop after this. I
Okay.
promise. I promise.
Go for it.
But
We got time.
no, I know. But I a student's gonna not remember 99% of the Calc 1 content I taught. The
Mm-hmm.
content,
Yeah.
they're not gonna remember it, or they'll faintly remember it.
Mm-hmm.
But the processes
Mm-hmm.
and the beliefs in themselves, that's gonna carry on with them later on, longer and longer and longer. And so
Yeah.
I do I do want to promote like a thoughtfulness around process, around Dr. Gutierrez talks about
Mm-hmm.
rehumanizing mathematics. I think about that a lot. How do we get people back? Because in Calc 1, I showed you that integral from 1 to 2 of x squared dx.
Mm-hmm.
Well, this device is going to calculate that way faster than you or I would.
Oh yeah. That's fantastic. I like that attitude a lot. I wish more I wish more professors had that attitude. Although I will say the on the plus side, it seems like something like that is becoming a more prevalent thought process.
Mm,
Again, personal experience, my opinion, but a lot of the younger professors, it seems like that are coming into teaching now have that same kind of mentality of not. It's not just
mm,
all right. I've got to slam through X, Y, and Z skills or concepts or whatever. But they're kind of going, all right, look, I want to hit these skills. I want students to remember them, but I want to do it in a way that sticks with them and not in like a traumatizing way, but something that they like a class they enjoy, that they want to be present for, and that kind of builds them up. I think that's just fantastic. All right, so I'll say if anybody in chat has any final questions, go ahead and get them in. I'm going to go ahead and cheat and ask Rama's last question. Uh, so
well,
yeah, go
uh,
ahead.
man, may I just jump in just a
Yeah,
second?
absolutely, please.
I think that what you just said, like, I think a lot about the environment that I'm creating around me.
Mm-hmm.
And what I mean by that is just the feel, right?
Mm-hmm.
And I think that everybody does this all the time. When you walk into a room or when you know that meeting is coming up,
Mm-hmm.
what do you feel? When you walk into that room, what do you feel?
Mm-hmm.
For some students, it's anxiety. For some students, it's boredom, right?
Mm-hmm.
For
Mm-hmm.
other students, it's fun, right?
Yeah.
I think about that question so often. I think about it when it comes to my home,
Mm-hmm.
right? What does a person feel when they come into my house? What did a person feel when they came into this chat,
Mm-hmm.
right? Like all of these things I think about a lot. And then I think about what actions can I do to create an environment where they can be more of themselves,
That's fantastic.
especially in STEM,
Mm-hmm.
where STEM is a place where it's highly, white male dominated.
Mm-hmm.
Um, to think about, like, not for myself, but for anybody else to just feel and know that there's an environment there that'll make them feel comfortable, you know?
Yeah, that's
Um,
fantastic.
yeah.
Yeah, I think I don't teach currently, but when I was at the University of Texas for about a year and a half, and I taught a chemistry lab course, and I actually was a TA and then became the instructor the next year. But between that point, the TAs all advocated for what amounted to a complete overhaul of the course, because it used to be it was in 3 week cycles, and it used to be that the students would do experiments all 3 weeks, and then by the next week write up a lab report and turn it in. As you might imagine, with 5 to 6 days to write an entire lab report, and this was like a junior senior level course, so not just do a simple reaction, weigh the product, and you're done. It was more complicated than that. They weren't very good reports, and so we ended up
Right.
taking student suggestions and basically saying, hey, we don't have enough time, and we overhauled it, made it to where it was still a 3 week cycle, but it was 2 weeks of experiments, and then the third week they could actually work in a computer lab with the TAs present, ask questions, say, hey, this is what we're thinking on the analysis and all that. And we made it more of like a journal style. So they didn't have that we had expected results, but if they got something that wasn't exactly as expected, it wasn't, hey, you got this wrong. It was, all right, tell us why this deviates from what you might have expected to see. And so they start digging
Yeah.
into
Yeah.
literature and basically defending themselves just like you would do, if you got a different result. And so
Yeah.
and that the class reviews got better. I remember there was the funniest review I had was something along the lines of, this was one of the hardest courses I've ever taken in my life, for especially for 1 credit hour, but I thoroughly enjoyed all of it, right? And so it's like that's what you're going for. You want people to
Absolutely.
enjoy what they're doing, even if it is difficult. And I think that's kind of what we're going for. It seems like.
It's it, it's challenge and support,
Mm-hmm.
right? I can
Mm-hmm.
hold you to a high standard,
Yep.
but I'm also going to try to support you the whole way. And one of the other things I wanted to mention is
Mm-hmm.
that you put your students first.
Yeah.
You did not put yourself first. And I think that's such an underrated quality of teachers, especially teachers that are trying to improve themselves.
Yeah.
The students are first,
Yeah.
and I can't thank you enough, and your team or whoever you worked with,
Mm-hmm.
for doing that for those students.
I appreciate that. It was a really enjoyable class. So we had a lot of fun doing that. So I will. All right. I'll go ahead and finish up with Rama's question to end it off.
I'm
Milosh,
ready.
what is the perfect circle?
And that's great. It's 10:58. We'll
Yep.
see you all later in Twitch land. Um, I hope you all enjoyed. No, this was fun.
Great. I'm glad you had a good time. Um, so with that, I think I don't see any more questions coming in, so we will wrap up. Milosh, let me get you to
Okay.
hang around for just a second, and we'll chat just a little bit more.
All right.
But I do want to say thank you to, of course, Dr. Savić for an absolutely fascinating talk. This was really cool, and I think it's going to give me and hopefully other people to some things to think about and maybe try and start implementing in our own teaching. Um, and yeah, so I hope you guys will come out next week. Trying to remember off the top of my head who we have next week, and I can't, but I know it's a good talk. Um, and you know what? I'm gonna pull it up real quick. Take a second and do that.
Okay.
Come on. There we go. Oh yes, Ross Kobe, who is going to be talking about mechanochemical synthesis of group two allele complexes. So we've had a couple of mechanochemistry talks in the past month or so. This will be another fantastic one. So I hope you all will come out and join us for that. I'm sure it will be a fantastic one. But for now, I hope you all have a great weekend. Please wear a mask. It's ridiculous. And I will hopefully see you all next week. And everybody have a great weekend.